Welcome to Light and Sound, lesson number 5, Refraction 2. We're on the very last part of this, where we're going to look at the eye. You've got to be able to draw a diagram of the eye, and you've also got to know something about short-sightedness and long-sightedness, the defects of vision here. So let's go to our notes, 5.4. So make sure your notes are downloaded so you can work with me throughout this class. So let's get to the eye, which is here. So there's a space here for you to draw a diagram of the eye. Now, you're not going to draw the eye like a biologist will draw it with all that kind of detail, because all we really want to see are the optical aspects of the eye. So let's go to the board and have a look at it in detail. The first thing you should be able to do is just draw the general shape of the eyeball. So it's spherical, maybe bulges a little bit at the front there. So see these parts here? I need to be able to label them on my diagram and just know a little bit about them. As I said, you don't need to know a great deal of detail. They just want the optical aspects of the eye. Well, the first part of the eye is the cornea. That's the clear, transparent part of the front of your eye through which light can enter. So we label that to begin with. Behind that, you're going to have the most important part of your eye, which is the lens. And we have a convex lens. It's going to form real images on the back of our eye. So let's label the lens. That lens can change shape. So you've got these muscles, these ligaments, ciliary muscles, that can actually squeeze it so it becomes thicker or more powerful, or stretch it so it becomes thinner. So that gives you the ability to focus on objects that are near, like when you're reading, or far away. Now, in front of the lens, you have the colored part of your eye, whether you have blue eyes or green eyes or whatever, and that's called the iris. So here's my iris here. There's a colored part that stretches down in front of my eye. So here I'm drawing someone who's blue-eyed. Now, the iris acts like a shutter. The point where the light enters through that tiny little hole in the middle of the colored part of your eye, in the middle of the iris. It's a little black spot, black being good because black will absorb everything. And that little black spot is called your pupil. So therefore, when you're looking at when you're in very bright light, the iris will shut down a little bit to stop light getting in. And when you're in a dark room, your eye will gradually adjust. The iris will open up, make the pupil as big as possible. And after a while, you can begin to make shapes out in a very dark room. So what are my main parts so far? The cornea, that's the clear part at the front of your eye. The iris is the colored part of your eye. It acts as a shutter, allowing more light in or less light in. The lens, that's a really important part. The lens, that is going to focus the light on the back of your eye. Let me write in the pupil here as well. The pupil is the little black spot in the middle of your eye through which the light enters. So they're the parts so far. So the light is going to come in, and that lens there is going to focus the light onto a screen. Now, the screen in your eye is called the retina. So you've got a screen full of little nerve endings that coats the back of your eye. Eventually, all the messages will go out through a part called the optic nerve. So this part here is the screen in your eye with thousands of little nerve endings that'll pick up the light signals. So the screen in your eye is called the retina. And all those little messages that get picked up, those little light messages that get picked up, will travel along the retina and eventually out to your optic nerve, which carries those messages to the brain. So any damage to your optic nerve is very dangerous, because if that gets cut in any way, then the messages that you see will not be able, you won't be able to process them in your brain. You won't be able to see. Actually, if light falls on that part there, that's called your blind spot, because the retina actually merges into the optic nerve there. So if the light falls there, that spot, you won't see anything. So the retina is your screen, and the optic nerve then finally carries the messages to your eye. And then what about the rest of the eye? Well, it's full of jelly, aqueous humor, vitreous humor. But look, we're physicists. We don't really care. It's a very simple diagram, and it's just showing the optical aspects of the eye. That's all we care about in physics. So you need to be able to draw that and to label it. So the next thing you have to know after drawing the diagram of the eye, you have to know defects of vision. You know, people who can see near and far objects well, but not the other way around, and how we can cure that using glasses. Well, there's two defects you're going to look at. You're going to look at short-sightedness. Know the definition for these. A short-sighted person, they can see near objects very well, but when they're looking at distant objects, it's all a bit of a blur. So short-sighted means I can see near objects well, but not distant objects. You've got a series of diagrams here, and you want to be able to draw rays on them to explain this situation. So this is a very popular exam question. So let me have a look at this in detail on the board. So we're talking about a short-sighted person. So a short-sighted person, well, I'm going to look at the first situation is everything is okay. So a short-sighted person can see near objects well. So let me put an object pretty close to the eye. So there's my object O. Now when you're looking at a near object, the rays of light can diverge a little bit and still enter your pupil. So let me take two rays of light coming off that. So here's my first ray of light entering the pupil, and here's my second ray of light. The diagram exaggerates everything a little bit, the sizes of everything. Now, I want those two rays of light to come together exactly on the retina. What you've got to do is, your lens has to do a lot of work. It's got to make itself very powerful. It's got to make itself very thick. So the ciliary muscles that control the lens will actually squash it. Now a short-sighted person has no problem with this. They're able to bend that light. So that light bends, and that ray of light will bend there, and the other ray of light will bend, and they'll meet at the same point. So you will end up getting a nice sharp image. So that's the okay situation. Everything is fine. Now what does this person have a problem with? They've no problem with that. They have a problem with looking at distant objects. So here's their problem. Well, if I'm looking at a distant object, the rays of light can't really diverge like that, or they'll just go straight over my head or down to the ground. They'll miss my pupil completely. So when you're looking at something far away, you're essentially looking at light that is coming in parallel to your eye like that. Any rays that are not parallel will miss the pupil. So you're essentially looking at parallel rays of light from a distant object. Now, in order to focus them, your lens gets thinner. The muscles around the lens will stretch it, it gets thinner, because it doesn't have to do as much work as over here. Look how much work this one had to do. That ray of light was going up. I had to turn it around and bring it down. This one is just going straight in, so it just has to pull it down to that point. The problem with a short-sighted person is no matter how hard their muscles work, they can't make their lens thin enough. Their lens is just too powerful. So what happens is when those rays of light come in, they bend too much. They bend quickly. And as a result of that, you can see in my diagram there that they will meet there. That's where the image is formed, which isn't where your retina is. So across your retina here, the image is kind of blurred. It's spread out across your retina. So no matter how hard you try, you can't make your lens thin enough. It's just too powerful. It bends the light too much. So I need some help, and the help comes in the form of a lens, and the kind of lens we get for our cure is going to be a concave or a diverging lens. So you know what your concave or diverging lens looks like? Well, this is what it looks like. This is what the lenses in the spectacles, the glasses of short-sighted people will look like. A diverging lens right there. Let me put in that central line that I bend the light about. Now let's look at the situation. So I'm looking at something far away. So I'm essentially talking about parallel rays of light coming in, but they hit my glasses first. And what does my diverging lens do? Well, those parallel rays of light will bend up or downwards. So, for example, that first one will bend up, and this one here will bend down. Do you know what it looks like now? It actually looks like the situation going back to diagram number 1. Look at the rays of light that are hitting your lens. They're just like that, those rays of light there. And look, my lens has no problem focusing those rays of light. So I'm actually looking at a distant object, but it now appears like I'm looking at an object close by. My lens has no problem focusing those. My lens is powerful enough to bend them down, and when they bend down, they're going to hit and come together exactly at the retina. So the cure for a short-sighted person is a concave or a diverging lens. So you need to remember that. So now let's look at the other defect of vision. The other defect is called long-sightedness. You need to know the definition. So a long-sighted person, they can see distant objects very clearly, but cannot bring nearby objects into focus. Like reading, which is close by, would be a problem. So let's look at that situation in detail on the board. So, a long-sighted person. Well, here's a situation where they're absolutely okay. They're looking at something far away. Far away, you're essentially looking at rays of light going in parallel to your eye from distant objects. That, by the way, is when your eye is most relaxed. Everything relaxes. The lens is as thin as possible. It's only when you're looking at close objects that your eye has to do a bit of work. Anyway, those rays of light are coming in parallel from a distant object, and your lens has absolutely no problem bending them by the right amount, and they give you a nice sharp image on the back of your retina. So that situation is okay. A long-sighted person can see far away objects nice and clearly. So that's the okay situation. But what's their problem? Their problem is trying to focus clearly on near objects. So here's a near object. O. And of course, if the object is close by, it's possible for diverging rays to be close enough to still enter the pupil of your eye. Now, what's the problem? Well, this person now has to make their lens more powerful. They've got to make it thicker. And the problem is they can't make it powerful enough. So we try to bend the rays of light, but what happens is I can't bend them enough. There's one ray of light, there's another ray of light, and they just can't bend enough. So you can see they don't come together on the retina. Well, if I could actually push my retina back, which I can't do obviously, then they would meet, they would be able to meet somewhere back here. So the image would form back there. So my image, if I could move my screen, my retina back, is formed there. We can't do that, of course. So what happens? Along the back of your retina, the image is a bit of a blur. So what I need is, I need a bit of help bending the light down. That sounds like a converging lens. So my cure in this case is going to be a converging or a convex lens. The optician will decide exactly what focus it should be. So in front of my eyes, I'm going to put in glasses that have convex lenses in them. So let me put in the dividing line down the middle of it. So what happens now? I'm looking at a near object close by. There's my object. And diverging rays of light can come off and still enter my glasses or my eyes. And what happens is that convex lens bends the light a little bit for me. So it's going to bend. So it bends like this. And now if you think about it, do you know what it looks like? It looks like the situation that I have back in diagram number 1. I've actually turned those diverging rays of light into parallel rays of light, like I'm looking at a distant object. And look, as in diagram number 1, my lens is no problem bending those so that I get a nice sharp image on the back of my eye. So the cure for being long-sighted, the cure is having a convex or a converging lens. So I end up getting a nice sharp image on the back of my retina. Okay, so know those diagrams very well. So in this part of the lesson, what do I need to know? A nice diagram of the eye, just showing the optical aspects, and I need to know defects of vision. What's short-sighted? Know the definition. What's long-sighted? Know the definition. And know your 3 diagrams for each of them. Just practice them and you are fine.